In this problem, we want to use trigonometry to answer the following question. An airplane traveling at 240 miles per hour is descending at an angle of depression of 5 degrees. How many miles will the plane descend in altitude in 4 minutes? Okay, so a couple of things. Of course, we're going to try to draw a picture, and even though we might think of normal airplane flight to, be horizontal once we've reached our cruising altitude, this plane is coming down. It has an angle of depression of 5 degrees. So we're going to draw this path, and as the plane is descending, this is where it is now traveling. It's no longer traveling along this line. Okay, but our angle of depression is 5 degrees, and we travel along this path for 4 minutes, okay, at a rate of 240 miles per hour. So one thing we need to know is how long do we travel on this path before we reach or for the 4 minutes. So we're going to use distance equals rate times time. The rate is 240 miles per hour. Okay, and our time is 4 minutes. Of course, I need to convert that to hours. So to do that, since I have minutes here in the top, I'm going to use a conversion factor that has minutes in the bottom. So I know that 60 minutes would be equal to 1 hour. Okay, so we've got 240 miles per hour times 4 minutes times 1 hour over 60 minutes. When we do that on our calculator, we get 16 miles. Okay, so now that we know that, this path is 16 miles, and what I want to know is, well, what's the change in altitude? So that's marked or noted right here. This is the change in altitude, and this is what we want to find. So I'll call it A for altitude, and see if we can find our answer from there. So I have three pieces of information that I need to tie together. I've got this angle of depression of 5 degrees. I've got the distance of my hypotenuse, because we have a right triangle here. And then I've got this other side that I'm trying to find. So what function ties those three pieces together? Okay, for this angle, this side is my opposite, and this is my hypotenuse. So I can say that sine of 5 degrees equals the opposite, which we've noted by A, over the hypotenuse. Or we can say that A is equal to 16 times sine of 5 degrees. And when we do that on our calculator, we get 1.39, which is a reasonable answer. This would be miles for change in altitude. Okay, we're not going to have large changes in altitude. So usually our answer will be somewhere between 1 and 2. But if you're getting, a huge number, then you've probably put this distance on the wrong side. This is the path of the plane as it is descending. It's no longer going along here. So if you put the 16 miles there, then that's going to mess your problem up. So this is where you want to put it, and then use the function that ties together this angle, the hypotenuse, and the opposite side, which would be sine. And in this case, we get 1.39 miles.